Hello, everyone. We are going to work on volumes of pyramids and cones today. This first slide I just put that in. We talked about it in the last lesson about how you would find the volume of each piece and add it together. I'm going to work that out in the notes in case you needed a little more guidance on that. I didn't work it out in the video yesterday, so I thought I would work it out in these notes, and then you can always I'm gonna have a Zoom today, so you can ask me any questions so far. All right, so here's where we're at volumes of pyramids and cones. And if we were in school, it'd be great because I could actually show you a visual model of what this looks like. And basically it turns out that if you have a prism and a pyramid with the same base area and the same height, the relationship is the pyramid's volume is 1/3 the same volume of the exact same prism with the same base area and height. So basically all we do is calculate the volume of the pyramid the exact same way we would calculate the volume of the prism, but then we have to divide by 3 or multiply by 1/3. So here's your formula for pyramids. And actually it'll be the same one for cones, but you take capital B, which is the area of the base, and then multiply by the height. Remember, the height is always going to be the perpendicular distance from the vertex here to the base. It always has to be perpendicular, so H is the height. So this first one will work out. Says find the volume of the pyramid, round your answer to 2 decimal places. All right, so we know our volume is 1/3 the area of the base times the height. The base is a regular pentagon. So for a regular polygon, our base is 1/2 the apothem times the perimeter times the height, and then times 1/3, or actually it's a lot easier sometimes to just hit equals and then divide by 3. All right, so let's see which things we have. Well, we know we're going to have to take 1/3 times all of this, and we have 1/2. We do know the apothem. This is the apothem right here. So we're going to fill in 2.8. And we know the perimeter. The perimeter is 4 times 5, or 20. And the height of the pyramid, again, has to be perpendicular to the base, is labeled at 7. So we'll multiply all of that by 7. Again, take your calculator out, work through these, make sure you know how to do these entries on your calculator so you're getting the correct answers. And if you do that, you can pause the video and see if you can get it, but you should get 65.3 repeating inches cubed. Volume is always in cubic inches. We talked about that as well yesterday. Or that's kind of the approximate answer. 65 and 1/3 is the actual answer. That's not rounded. Neither is the 0.3 repeating, I guess. But so we really don't need approximately equals to. We can actually just go with equals. And you could list it either way. All right, so that was pretty simple. We had all the things that we needed. This one, again, I'm working through some of these ones that involved special triangles or trig. But this, we're going to find the volume by taking 1/3 the area of the base times the height again. And again, we have a regular hexagon here, so we have to take 1/2 the apothem times the perimeter and times the height. So I always start with generic formula and then I fill in everything I know. Well, that does not look like a 1/3, so let's change that part. So 1/3. All right, so now I have 1/3 and then 1/2 the apothem. I don't know the apothem, but I do know the perimeter. Okay, my perimeter is 8 times 1, 2, 3, 4, 5, 6. So 6 times 8 is 48 for my perimeter, and I do know the height of the pyramid is 8. So I can plug that in. So the only thing I need to find here is I'm going to need to find that apothem. So remember, inside here we have all of these isosceles triangles. Okay, the apothem is the height of one of them. So basically, if I pull out that triangle, half of it right here, here's my apothem. This whole base is 6, so this is half of that 3. So now I'm looking at this triangle right in here, and I'm trying to find that apothem. Well, I also have to figure out what is the degree measure. Well, 360 divided by the 6 angles that are in there for all 6 of those would give you 60 degrees. But then this piece of it is just half of it, so you get 30. And this is that nice 30, 60, 90, where our relationships are the shorter leg is x, the hypotenuse is 2x, and the longer leg is x root 3. So that makes our apothem right here is 3 root 3. So we can put in 3 root 3. Or if you want to get a decimal approximation for that, you could do that also. That'd be about 5.2. But I just like to usually leave it all together. So now if we multiply all these things together to get our volume, we should get approximately 332.8 centimeters cubed. Now this says round to 2 places. That's going to be a little bit different depending on if you use 3 root 3 and that whole value of 5.196, etc. So if you put in a 5.2 here, that's rounding that to the nearest hundredth, it's 5.20, that's going to give you this answer. Let me clean that up a little bit. And let's put it in as 5.20. That's going to give you approximately this answer. If you do the 3 root 3, then you take 0.5 times 3 root 3 and times 48 times 8, and then divide that by 3, and that gives you approximately 332.55 centimeters cubed. And I know some of you had questions about like on the test, like with rounding and so forth. Well, I went back and allowed for all, like a lot of different possibilities. So don't worry too much about that. Just make sure that you are trying to keep it as exact as possible and then round at the end. But you can see how you can be a little bit off that way depending on what you use. Okay, so this problem I'm not going to work out, but again, I have some problems in here that you can check back. You can try the problem on your own, and then you can check the notes for the answer and solution. So let's try one where we're doing a pyramid volume and working backwards. Okay, so it gave us this volume. It gives us the volume, and we're supposed to find x right here. Okay, and x is one side or of the regular polygon. So our volume is 1/3 the area of the base times the height. So again, we're going to put in our volume, because we know that, equals 1/3 times the area of the base. Well, the base is x by x. So my area of my base is x squared times my height, which I'm given as 15. Okay, so now you can kind of multiply these three numbers in any order. So if you multiply the 1/3 and the 15, that works out to be just 5, which makes it kind of nice. So you get 5x squared equals 605. Divide by 5, you get x squared equals 121. And so your value of x is equal to 11 meters. So working backwards, practice some like that as you choose some problems later on. Again, here's another one where you're working backward. I'll work that one out for you for extra practice so that you make sure you're being successful as we work through these, and you'll be successful on our last test next week. All right, so let's move on to volume of a cone. Well, just like prisms and cylinders really have the same formula for volume, okay, so do cones. We take 1/3 the area of the base times the height. It's just that in this case, our base doesn't change. It's always going to be a circle. When you look at a pyramid, it could have different shaped bases. So really, you could use this more specialized formula if you want, but I just go back to the same basic generic formula and then remember that my base is a circle. So for this problem below, if I'm finding the volume, I'm taking 1/3 the area of the base times the height. My base is a circle, so pi r squared times h. And so now I just plug in what I know. 1/3 times pi times my radius squared times my height. Oh wait, I don't have my height. Here's my height over here. What I'm given right here is actually the slant height, and I need the actual height right here. So how do we do that? Well, we can go back here and use the Pythagorean theorem because this is a right triangle. So h squared plus 4 squared equals 2 square root of 15 squared. And don't get a decimal for 2 square root of 15 squared, because when you multiply 2 square root of 15 times 2 square root of 15, you get 2 times 2 times the square root of 15 times the square root of 15. Well, square root of 15 times the square root of 15 is just 15. So 15 times 2 is going to give you 15 times 4, or 60. So now I have h squared plus 4 squared equals 60. Now I subtract 16 from 60. I get h squared is equal to the square root, or sorry, I went a step ahead here. H squared is equal to 46, and so h is the square root of 46. And you can just leave it again. That will be more exact if you put it in like that. So now I'm going to put that in for my height rather than a rounded answer. Now, when I multiply these all together on my calculator, I should get approximately 113.64 units cubed. And if you prefer, you could have put a decimal in there, but I believe this is the more exact answer. I'll calculate it out. If you do 4.6, you would get, your height would be more like 6.78. So there will be some variation depending on how exact you make your answer. So, let's move on to another example. I'm just finishing calculating this. Yeah, this is with the square root of 46. So if you do it with 6.48, you're going to get a slightly different answer. Again, here's one where I will work out the problem with you, and then we'll have another one next that you can try on your own. Okay, so this one, find the volume of the cone. Volume equals 1/3 the area of the base times the height. Well, my base is a circle, so pi r squared, times my height, which is 5, and I'm going to take 1/3 of that. What I'm missing here is my radius. So I need to find this radius. I don't have my slant height, so I can't use the Pythagorean theorem. So what I'm going to need to do to find this radius is I'm going to need to use trig. This is a right triangle right here, and I know that this is a 70-degree angle right there. That's marked. And I know from that 70-degree angle, I know the side opposite, and I know the side adjacent. And opposite and adjacent are tangent. So the tangent of that 70-degree angle is equal to the ratio of dividing the side opposite over the adjacent. So now I'm going to solve, okay, by taking the tangent. Actually, I'm going to end up with I'm going to actually use the means exchange. And if I exchange these two right here, I end up with r is equal to 5 divided by the tangent of 70, which my radius then is approximately 1.82. So now I can put that in for radius, 1.82 squared times 5 times pi, and then times 1/3. And when you multiply all those together, you get approximately equal to 17.34 feet cubed. All right, here's one you can try and then check back for the answer. And then last but not least, we're going to find the volume of kind of a combined solid. We did this a little bit on in some pieces in chapter 11, and it's also some surface area applications. Here, we don't have to subtract anything out because we're talking about volume. We won't be subtracting anything. So we're going to basically find the volume, get some different colors here. We're going to find the volume of that pyramid, and we're going to find the volume of the prism and add them together. So the volume of the prism is the area of the base times the height. The base area is 8 times 8, and the height is 5. I don't know if you see that over here, but the height is 5. So the volume of the prism is 320 meters cubed, excuse me. Now let's work on the volume of the pyramid. Okay, so now we find this volume. That volume is 1/3 the area of the base times the height. So 1/3, the base area is the same. You get 1/3 times 8 times 8. And the height in this case is 6. That's the height right there. So multiply that by 6. So this volume is 128 meters cubed. So now I simply add those together. So to find the volume of that solid, I take 320 plus 128, and that gives me 448 meters cubed. All right. I guess I kind of left out my V there. So that's basically volume, okay, of pyramids and cones. Here's another problem. I'll work this one out in the notes again. This one you're not going to be adding, okay? You're going to have to find the volume of the prism, and then you're going to have to subtract that cone because that's not involved in it. It might be kind of confusing, but that's what they're intending. So here are your learning targets. Here is your homework. Okay, you are going to actually again decide, okay, so you decide how many of these you feel like you need to do to be successful. Here's a starting point, but that might not be the only questions to do. Look around. If you're struggling with the certain trig areas and things like that, do some more of those. And again, I will be looking for the course update. I'll be hosting a Zoom session tomorrow so that you can let me know if you have questions from the quiz that'll open up or any of the volumes so far. Have a great day.